Good morning, good afternoon, good evening, wherever you may be watching this video from. This is Cornelius doing with another video representing ZSTEM Hub. And in this video we are answering the 2024 paper 1 internal question 8, additional mathematics. Alright, so let's get on with the answering. This is a 2 hours paper, and the question 8 reads, given that y is equal to 2x plus 3 to the power 2. They want us to find dy dx, and then b. Two variables x and y are related by the equation y is equal to 3x minus 1 times 2x plus 5. Obtain an expression for dy dx and find the approximate change in y as x decreases. Take note, decreases from 1 to 0.95. As we can see, calculus is a very important topic. Just this question alone, it is carrying about 9 marks. The 6 plus 3 marks there. So let's get on with answering question 1. Sub question A, which says given that y is equal to 2x plus 3 raised to the power 2. Okay, so for question 8a, y is equal to 2x plus 3 raised to the power 2. Let's just try to counter check. Okay, so as you can see in this particular question, it is a composite function. Okay, how do we differentiate the composite function? We use the chain rule, right? Where this is we'll call method 1. So we can say method 1, in which we are considering the equation y is equal to 2x plus 3 raised to the power 2. So the first thing to do, we'll say, is let u be equal to what is in the parentheses or what is in the brackets, and we have 2x plus 3. So we'll say 2x plus 3. So I hope it's clear so far. So we have said u to be equal to what is in the parentheses or the brackets. Then what has remained is going to be our new function, which is y. What has remained? Take note, u is equal to 2x plus 3. Now, what will our y be? Y is going to be equal to, instead of writing 2x plus 3, we're going to write what? U raised to which power? In this case, it's power 2, because u is 2x plus 3. Now, since we had the square there, so set the power 2. And then, what do we do? So it's like we have formed two functions. Function in u, function in y. The variable for the function in u is x, and then the variable that we're considering for the function in y is u. I hope it's clear there. Then we just differentiate the two new functions. What do? We say du dx is equal to, derivative here is what is y dx of, or rather, since I'm using du dx, what does that mean? It means I'm differentiating the function that, is starting with u. It's function in u. The variable is x. That's what I mean. So if you differentiate anything having x here, you can see the 2 has x, which is the term is 2x. Derivative there, derivative with respect to x is going to be 2. The derivative of a constant is 0. So we don't need to write it. dy, because y is the function in question, with respect means, so that's why I write in du, so with respect to u is equal to, this side we have the u, we differentiate the u. Here, what are we going to do? We're going to use the power rule, which is going to be 3u. Essentially, what is happening here is that, sorry, not 3u, sorry, 2u, whatever I written, 2u. Essentially, what is happening here is that the power 2 there is going to multiply the function, so it's going to be, it's like we're saying is equal to a 2 times u. Okay, it's being raised to power 2, and then from this power 2 we're going to drop the power by 1, right? And then we're going to end up having a 2u the power 1, which is just the same as a 2u. That's what's essentially happening there. So what have I done? You have u there, you have y there. Differentiating u, du dx, differentiating y, dy du. And then the chain rule. So the chain rule comprises of these parts. What we have differentiated here, du dx, dy du. So we'll say that dy dx is equal to dy du multiplied by what? Du dx, in such a way that, you know, the u's cancel out here, cancel out like that, and then you remain with dy dx. That is a good way of remembering, but mathematically we can't just cancel out du and du. So that's not mathematically correct, but it's a good way of remembering. That's why we are saying in such a way that du and du cancel. We're not saying that essentially when you find du, you can cancel them out, because, you know, you have found du and you know it's cancelling out somewhere. You end up confusing yourself, you end up overthinking. So this is the way of remembering. Don't need to overthink here. Yeah. So this is the formula. We just plug in now. So it's equal to dy du, which is 2u multiplied by du dx. Du dx is a 2. I hope you can see the 2 there. Yeah. Multiply by 2. Multiply the numbers that you can see. 2 times 2 is a 4u, and therefore you can just conclude by saying therefore dy dx is equal to a 4 times u, which, remember, 2x plus 3. Don't forget about what your u was, and that would be a final answer for your dy dx, 4 times 2x plus 3. And yeah, that's it for method 1. Then there is another method which we call method 2. So we can say method 2. Sorry, method 2. How do we do it? The particular function in question is y is equal to 2x plus 3 raised to the power 2. What we have to know is this. I hope okay, the language here is sometimes confusing. That's why people go for method 1, you know. But if you follow me closely, the language won't be very confusing. So this, what is inside the brackets, is called the core. Okay, It's called the core. I hope you will remember that. So the formula for finding dy dx is what? We will say dy dx is equal to n. Okay, first of all, let's write, okay, let me just clean up. I write this in a different way so that it can make sense. So you have your core there, right? Let's consider the core being raised to a particular power. So we will write our brackets there, power n, then inside we're going to have the core. So what am I trying to say? So we have y being equal to this particular function. If we differentiate it, it is dy dx is equal to n times the core. Okay, n times the core, then then n will lose one power. So essentially we're just doing a normal differentiation. So n times the core, then n will lose one power. I hope that's done. I hope that is clear. Then multiply by derivative with respect to x, so d dx of the core, So the derivative of the core is what I mean, and this is your equation. So I don't need to know this. You don't need to know how to write this. Just know the language behind it, or what is happening. So what is in question for us is y is equal to 2x plus 3 raised to the power 2, right there. So if we were to differentiate it, it means we would say that dy dx is equal to, the power is 2 multiplied by, what is the core? 2x plus 3. So because it's 2 multiplied by the core, then the core will lose one power, so it's the power 2 minus 1. What is the derivative of what you can see inside in here? 2x plus 3. Derivative there is a 2. And then dy dx will be equal to, what is a 2 times 2? It's 4, multiplied by 2x plus a 3 to the power 1. As I earlier said, the power 1, you don't need to write it, so this is your final answer, which is the same answer which we found this side. So whichever method you may want to use, it will still land you with those needed 3 marks, like that. Can you see that? 3 marks there. Then they are saying two variables x and y are related by the equation y is equal to 3x minus 1, and that is being multiplied by 2x plus 5. Then they want you to obtain an expression for dy dx. So that's important. That's actually a question. Obtain an expression for dy dx and then find the approximate change in y as x decreases. So it's reducing from 1 to 0.5. So for here, finding the derivative, we know what to do, right? We are clear. So for b, you can use the product rule. Okay, you can also use, you can just expand the brackets and then you remain with one function, then differentiate. Now b would have made sense if there was power 6 there. Okay, just imagine if there was power 6 there. So it means that the product of the function y is equal to 3x minus 1 multiplied by 2x plus 5 raised to the power 6. Then the product would have made sense here. But you can do it by yourself. I'm not going to do the product in this video. I am just going to explain using the chain, the power rule. There is no need for even a chain rule here. You're going to see how this is going to just simplify. So the function in question is 3x minus 1, 2x plus a 5. 3x minus 1, then we have 2x plus a 5. And this is b. Y is equal to 3x minus 1. I hope you remember that I said 2x plus a 5. Like I said, since two functions are being multiplied here, you can use the product rule. Now, that is an unnecessary method for this question because you can simply expand. So which is equal to 3x multiplied by 2x, it will be 6. That is the coefficients. Then variable x squared, 3x times that, plus 15x, then minus 2x, negative 1 times 2x, then minus 5. So it's like we're just expanding. Okay, that is minus plus minus plus. That's why the final sign is a minus. You see why? Sorry, I forgot to simplify here. So 15x minus 2x is 13x, and then minus a 5. This is our final function. This is the function. So it's like they just, solved it and expressed it in terms of the factors, 3x minus 1 times 2x plus a 5. But this is the quadratic equation in question. So you could have used the product rule, spent a lot of time, precious time in the exam, but this is the best. You differentiate this one now, you're going to have dy dx is equal to 12x, then plus 13. I hope we know how to do a basic differentiation, because this differentiation is one which is even required in your mathematics. Now, if you do not know mathematics differentiation, and then this one also becomes difficult. So it is just simply 12x plus 13. You have seen? So this is an answer. Alright, so that is your expression for dy dx. Simple as that. 12x plus 13. So if you use the product rule, you will end up with this. Okay. So we continue. Now, they want you to determine the change in y as x decreases from what number was that? 1 to 0.95. The approximate change in y as x decreases from 1 to 0.95. So there, don't also overthink for that one. It is simple. Just need to consider a few things. So I need to know, what do they mean as x decreases from 1 to 0.95. So what do you need to think about when you see such a language? You need to think about change. What does change mean? Delta, right? So because change means delta, you're going to represent the change in x as delta x, and then the change in y as delta y, where we're going to say delta x, that symbol, you just do this s, and then it continues like that. I hope it's clear. Delta x, which is equal to what it was. It was 1, decreased to 0.95. So how do you find the change? What has it become? It has become 0.95, right? 0.95 minus 1. So when you subtract these two, is your delta x, because it was decreasing. But the way we subtract is we subtract what it was from what it has become, from 0.95. So 0.95 minus the 1, you're going to have negative 0.05. Negative 0.05. I hope that's clear. Yes. Then after knowing that, you need to know this particular formula. This one just need to master it. It's just something that will help you to know the change in y. Okay? Because another method you can use is you can find this is your change in x, right? So you can substitute your old x value, which is 0.95. I mean, your old one was 1, and then your new one is 0.95. You substitute it into the y function. You subtract the 2, that will be your change in y. The 2 answers you find, that is your change in y. Now, to avoid all that, there's a formula, which is delta y, change in y, is equal to the derivative of the function itself, dy dx, where x is equal to a constant multiplied by delta x, delta x, the change in x. So how do we proceed here? Dy dx is what we found here, 12x plus 13. So you just say is equal to 12x. You always consider the initial x value, which was 1, because it's decreased from 1 to 0.5. So we're considering 1, then plus 3. Okay? That's it. That was your dy dx. Then you can put this in parentheses. You can say where x is equal to the same one that you have substituted, which is the 1. Then you multiply by what? Your dy dx, your delta x. Your dy dx, of course, is the 12 multiplied by 1 plus 3. Delta x, change in x, negative 0.05. Yes. So is equal to, we have 15 here, which is 15 multiplied by negative 0.05. Then this particular point will say, therefore, delta y is equal to, what answer we're getting? 15 times negative 0.05. We're going to have negative 0.75. And this is our change in y. Yeah, so that's what they would expect you to do. Just substitute accordingly, like that. Simple. Have you seen how you have found that you are changing y? Just need to know that particular formula, which is really scary in the beginning, but as you go on, you're like, I know this formula is okay. With more practice. And have you seen how fast we have found our change in y? We just needed to plug in x is equal to 1 into that formula and find our delta x. Then we found change in y as that. Thank you so much for watching this video. This has been connected to be with another video, and bye bye.